Ever wondered how electric vehicles keep their batteries from overheating? Managing heat is critical for performance, safety, and battery life, and that's exactly what thermal management is all about. Let's decode the science behind battery and EV thermal systems. Let's dive into the thermal characteristics of lithium-ion batteries, focusing on how heat is generated. There are two primary sources of heat in a battery: internal resistance and electrochemical reactions. To make these concepts easier to understand, let us use a couple of analogies. First, let's talk about internal resistance. Imagine a busy highway where cars represent electrons. If there's a traffic jam due to road construction, the cars, just like electrons, have to slow down. This leads to frustration and inefficiency. Internal resistance in a battery works in a similar way. It slows down the flow of electrons, causing energy to be wasted as heat. Just like cars stuck in traffic generate heat from friction, the energy lost due to resistance in the battery results in increased heat. Now, let's consider electrochemical reactions. Picture a busy intersection where some traffic lights are malfunctioning. Cars stop and start repeatedly, and each time they accelerate, their engines work harder, generating additional heat. In a battery, electrochemical reactions are akin to those accelerations. Every time the battery is charged or discharged, these reactions release energy as heat, contributing to the overall temperature. Understanding these sources of heat is vital for managing battery performance and safety. Now let's build our understanding on top of the analogy we just saw. First, there's internal resistance. Every battery has some resistance within its materials, like the electrolyte, separator, and electrodes, which resist the flow of current. When current flows, this resistance causes some electrical energy to convert into heat, and the higher the power demand, the more heat is produced, further increasing the cell temperature. Then, with electrochemical reactions, whenever the battery charges or discharges, lithium ions are shuttling back and forth between the anode and the cathode to generate electricity, as we saw in the battery chemistry lesson. But this process isn't 100% efficient. Each movement of ions result in a little bit of energy being lost as heat, especially at high charge or discharge rates, causing the cell's temperature to rise. Together, these factors lead to temperature rise, which can affect the battery's performance, safety, and overall lifespan. If you found this useful and want to learn more about how EVs, batteries, and energy storage systems manage heat, check out the full course in the description. Don't forget to subscribe for more insights into EV thermal management, battery tech, and cooling strategies.